Have you ever been at a stoplight and glance over and see a loud, shiny muscle car next to you and mutter, among other things we won't say here, that thing must be spewing up pollution by the bucket load? Well, we all breathe the same air, and we should all be concerned if someone is unduly polluting it. But before berating that muscle car owner, consider this. In 2004, California Assemblywoman Sally J. Lieber penned Assembly Bill AB 2683, which requires that cars built after 1975 pass a rigorous smog inspection, and the permissible limits on emissions are very low and very difficult to meet. I am one of those muscle car owners, but my vintage car has a unique problem. It is new enough, a 1979, that it has to pass inspection, but it is old enough that it does not have an onboard diagnostics or OBD computer system that were rolled out in 1980 to keep the engine running clean. In 1979, all the controls were mechanical. If something goes out of adjustment, and I wouldn't know until I failed a test and drew the ire of the law. This talk will describe a solution to this predicament, how to measure in real time and optimize for the lowest emissions the air-fuel ratio of a pre-OBD vehicle. It turns out that some of us motorheads take emissions compliance seriously. I recently swapped a new engine into my muscle car, implemented a full suite of emissions controls, and demonstrated compliant emissions to the satisfaction of the California Air Resource Board referee. The key to the success is understanding something called stoichiometry, the ideal air-fuel ratio, measuring the car's actual air-fuel ratio under real driving conditions, and finally, adjusting the ratio for the lowest emissions. But first, a little chemistry lesson. The stoichiometric ratio means that there is an oxygen molecule for every hydrogen molecule being burned. For gasoline, that ratio is 14.7 parts air to 1 part fuel. As Marcus Hilgendorf explains in his 2004 paper for Topics and Catalysts, I know you guys all subscribe to that, if there is not enough oxygen, if the mixture is too rich, unburned hydrocarbons, HCs, and carbon monoxide, CO, are released into the exhaust stream. On the other hand, if the mixture is too lean, too much air and not enough fuel, the mixture burns too hot, and oxygen combines with atmospheric nitrogen to make a nasty soup of nitrogen oxides, or NOx. NOx, among other unpleasant things, turn the air brown. The stoichiometric ratio is what we want. But what if the car isn't achieving that? We'll have to measure it. Enter the oxygen sensor. Jasinski's 2006 article in Material Sciences Poland gives a crisp definition of how the wideband oxygen sensor works. By comparing the exhaust stream to the surrounding atmosphere, this device gives a signal that is proportional to the air-fuel ratio. All we need to do is install one of these little sensors in the car's exhaust stream, and then use a simple for 2019 and maybe not so simple in 1979, computer to convert the reading into a fuel-air ratio that we can see and display it on a gauge. With that done, we will now know the ratio under real driving conditions. But what if it is not ideal? We might need to get our hands dirty. Recall in 1979, all the controls are mechanical. The device that sets the air-fuel ratio is the carburetor. Inside the carburetor are metering rods that react to engine load and set the ratio by metering fuel. we have two knobs to turn to get to that 14.7 ratio that we desire. If we are way off, we can exchange the rods for thinner one to allow more fuel to the engine, or thicker ones and act as a constriction and reduce the fuel to the engine. Once the correct metering rods are chosen, we can adjust them very, very finely up and down in this tapered section to precisely hit the optimum air-fuel ratio. Applying some 21st century technology to this awkward in-between years car makes it as clean running as a much newer car. By understanding the chemistry of stoichiometry, how to measure it, and then adjusting it, these cars can run clean and we can all breathe a little easier. Now this all means, of course, that when you glance over at me at the stoplight, you might mutter something you can say out loud to the kids. Maybe even give me a thumbs up.